Okay guys, so we're going to start talking about graphing. So after your 20-day assessment, we normally move on to different topics. So we're definitely doing that today, moving on to a different topic. So on page 24 of your notebook, I want you to go ahead and label it 3.1, graphing relationships. And you're going to label 24 and 25, graphing relationships. So 3.1, graphing relationships. Okay, then you have a foldable. Looks like this. If you don't have it, of course, you're writing the answers and stuff down on page 24. Okay, so these examples here are talking about graphing things. So it says the distance a delivery van is from the warehouse varies throughout the day. The graph right here shows the distance from the warehouse for a day from 8 a.m. to 5 p.m. Segment 1, right here, shows that the delivery van moved away from the warehouse. What does segment 2 show? Take a minute. I normally make the students do this on their own. Take a minute and answer these questions. If this is moving away, well, so is segment 2. The truck moved away. However, it looks like maybe at a slower speed, since the slope is not as steep. As in 1. See, 1, it was very steep. 2 is not, so we're going to say it's at a slower speed. Letter B. Based on the time frame, what change in the distance from the warehouse is represented by 6? Notice it goes away, away, stays, away, stays, going back towards the warehouse. So maybe it is that the truck begins to return to the warehouse. Maybe it's the middle of the day and it's time for it to start to go back. So the truck begins to return to the warehouse. Letter C. Which line segments show intervals where the distance did not change? So this is going away, away. Oh, it's flat. It's not changing. 4 is going away. 5 is flat. It didn't change. 6 is going down. 7, it did not change. 8 and 9 are going down. Okay, letter D. If you are working on this on your own for a minute, and I want you to pause it and answer question D. It's talking about these segments. Why are they flat? Your answers may be different than the ones we write down, and that's okay. All right, so letter D. What are the possible explanations? Okay, it's a delivery truck. Maybe the truck is making deliveries when it stopped. Maybe number 5 is lunch. Maybe 3 or 7 they had to go get gas. There are a lot of possibilities. I'm going to just write one. The truck was making deliveries. But any of the ones I mentioned, and any that you might know of, are appropriate. As long as it makes sense for a delivery truck, it's appropriate anyway. Okay. Now let's look some more at graphs. Okay, you and a friend are playing catch. You throw 3 different balls to your friend. You throw the first ball in an arc, and your friend catches it. I'm going to highlight these so that I can pay attention to the 3 different things that are happening. I got 3 graphs. I got 3 things happening. Okay. So the first sentence says, you throw the ball in an arc and your friend catches it. Next, you throw the second ball in an arc, but this time the ball gets stuck in a tree. And third, you throw the third ball directly at your friend, but it lands in front of your friend and rolls the rest of the way on the ground. The three graphs are shown below. We're going to match the three graphs. Before we even answer the questions, we're going to match these graphs. So let's think about the first one. You throw the first ball in an arc and your friend catches it. Well, this looks like it hit and then it's on the ground. Your friend's not on the ground. It doesn't say your friend's laying on the ground. All right, B, it goes up. Maybe your friend catches it. It looks like it's the same height. So if you and your friend are the same height, that could be it. All right, this one goes up, but then it stays up. So I'm assuming here that it's probably B. Okay. The third one, you throw the ball in an arc, but this time it gets stuck in a tree. Well, the tree's high, so it's probably C. And last, you throw the ball directly at your friend, but it lands in front of your friend and rolls on the ground. A. Now we're going to answer the questions, now that we've matched them. Number 3, which graph represents the situation where the ball gets stuck in a tree? Well, thankfully we already did this, so it is graph C. Describe the height of the ball represented by the other two graphs. Well, we've kind of already done that. Graph A. So since we've already identified it, we're going to write something short. Lands on the ground. We're not going to write the whole thing, but we know that graph A goes with the one that lands on the ground. Graph B was caught by our friend. Today, in your assignment, you will have somewhere you have to identify things like this with these graphs, okay? If you have a printer and have printed this off, fold this in half and glue it in. If not, you've written on page 24. So this part doesn't apply to you, and you could skip over it for a minute. Don't skip too far, you don't want to skip the whole thing. So this goes on 24. There's the title again in case you missed it last time. Okay. If you are at home and don't have a printer, you are now writing on page 25. We're going to keep going with this one. So 25 is what you're writing on now. Okay. I'm going to take this foldable and fold it in half. I will also need highlighters. If you're at home and don't have any of that stuff, just write everything down. You'll be fine. All right. We're going to talk about graphs and the differences between graphs that are continuous and discrete. And we had continuous graphs just a second ago. A continuous graph is usually the result of measuring, and I'm skipping to continuous first because we just saw those. It can take any value within a certain range. So we kind of just talked about that, like a line is a continuous graph. All of the three balls were continuous graphs. So some examples, a weight of a baby can take on anything within a range, as can the height of a student. Okay. Now discrete. Discrete is like counting. So if you're in my class and I've got 27 students, that is discrete, not continuous. Because continuous is any value within a certain range. Well, discrete is only certain values. I can only have a certain number of students. I can't have anything within a range. Why can I only have certain values? I can't have half a student. I either have 27 or I have 28, but I can't have 27 and a half. It looks like this. It's just distinct points, okay? That is a discrete graph. For instance, number of pizzas ordered. They won't let you order certain types of pizza. They won't let you order half a pizza. Or number of students in a class. That is the difference between continuous and discrete. And we do talk about these a little bit more as we go through, okay? Not only are we going to talk about continuous and discrete today, we're going to talk about domain and range. And we're going to do that on the inside here. So domain and range, continuous and discrete. I want you to go ahead, take this, and draw a line. The top portion is discrete because they're specific values. The bottom is continuous. I also want you to write down that the domain is x values, the range is y values. You write it for all of them, that's fine, I don't care. Okay, so we're going to talk about domain and range. Domain today we are going to highlight in green. We won't be able to highlight everything, and you're going to see why. If it's on a graph like this, we're not going to be able to highlight it. We'll do our best, but we're not going to be able to highlight great. So domain we're going to highlight in green. In a discrete function or relation, a domain is written with curly brackets and then these values. So x values, -2, 0, 1, 6. -2, 0, 1, 6. That is the domain for the first one. The range, we're going to highlight that in orange today, are the y values, 3, 4, 1, 0. And I write that with a curly bracket as well. I write curly brackets with all discrete domains and ranges. 3, 4, 1, 0. There is the domain and the range. The next one. This is what I meant by I'm not going to be able to highlight all of them. Here's the domain. The domain is the x values. Still going to use curly brackets. But now I have to read them from a graph. This point is at -4. This point is at -1. This point is at 2. This point is at 3. That's the x values. Range is the y values. Okay, so I'm going to start down here. -2, 1, 4, 5. Okay. I want you to pause the video and find the domain and range for the next two. I hope you have paused it. Domain is the x values. Now, if you did pause it, thank you. If you didn't, pause it now. But the domain and the range, I'm just going to write them down, but you do not repeat values. See how it's -3 and -3? I only need to write that once in the domain. So if you wrote it twice, because I didn't tell you that before you started, erase the second -3 and the second 2. For domain and range, you only have to write it one time, no matter how many times it's there. Range is y's. So I got 6, -5. I've already got 6. 0, -3. So if you've got 6 written down 3 times, erase 2 of them. You don't need to write it twice. But like I said, I didn't tell you that before. Okay. Then you got the range and the domain for the last one. You have 4 points. 1, 2, 3, 4. All right, this one. 1, 2, 3, 4. 1, 2. 0. -1, -2, -3, -4. And then the range. The domain. I should have done domain first. Okay. -1, 2, 3. -2. 0. 1, 2, 3. I almost said 4. 3. This is how discrete graphs, domain and range is written. It's written in curly brackets. You need to know the difference between a discrete domain and range and a continuous domain and range, okay? We are going to now look at continuous domain and continuous range. Still need your highlighters. Okay, domain. Again, it's the x values. Here's what I have to pay attention to. Remember a few seconds ago, minutes, whatever, we talked about how discrete is only certain values. That's why we only listed very certain points, okay? Continuous is any value within a certain range. We are going to write down a range. We're going to use a compound inequality to do that. Domain is x values. I'm going to look, notice how this x value right here is at -2, and it goes all the way to 4. So I'm going to write down, it went from here to here, that this started at -2, it ended at 4. What that means is I'm going to write the compound inequality, -2 is less than or equal to x, because it's domain, is less than 4. I did not put a or equal to, because notice how that's open, notice how this is closed. This is how I write domain for a continuous graph that has endpoints. Let's do range. Range is the y's. I am going to start down here at -2, since that's where it starts, and I'm going to go up to, looks like 3. That's -3 to 3. I'm going to write the same thing. I'm going to start with the negative number, -3, less than or equal to, because it's closed, y because it's range, less than because it's open, 3. That is how I write domain and range for a continuous graph. Okay? Let's look at domain and range for this next one. Domain is the x values. Here is x. It starts at 0, and then it keeps going. Notice how it has an arrow? That means it goes on forever, which means it's not a compound inequality. It's just a regular inequality. It is x is greater than or equal to, because it's closed, 0. It is every single x value bigger than 0. Okay, now let's look at range, which is y's. Again, this starts right here, and it goes, notice it, you can't see it right here yet, but it eventually will get up there. It's going to keep going all the way up, so range is also, it's y, but it's also greater than or equal to 0. So it is either a compound inequality or just a plain inequality. It is a set of numbers, though. I want you guys to try domain and range for these two. All right, let's get started. Domain. Well, this doesn't have a starting point, really, because it goes all the way over here, and it goes all the way over there. Since it has arrows in both directions for x, that means this is actually all real numbers. You can either write all real numbers, or there is a math symbol that is 2 lines and a R. That is not IR. It is 2 lines and a R. That means all real numbers. You can either write all real numbers or that symbol. That means every single x value is accounted for. All right, range. Does it have a starting? Yep, it starts down here and it goes up. And it looks like since it's going up in both directions, it's going to go on forever. So it's going to be y is greater than or equal to solid something, -1, -2, -3. There's the domain, there's the range. Okay. Domain, where does it start on the x's? Looks like -5, and it goes to 1. I'm going to have to really count. -1, -2, -3, -4, -5, -5. 1, 2, 3, 4, 5, 6. -5 is less than or equal to, because it's closed, x, which is less than, because it's open, 6. Range. Oh, it starts down here. And then it goes up to right there. Notice how there are no little holes right here? That means they're both going to be or equal to, okay? All right, we got to figure out where this is. -1, -2, -3, -4, -5, -6. 1, 2, -6, less than or equal to y, less than or equal to 2. Okay. You are going to glue this in on page 25. We're going to glue this in on 25. You're going to do the assignment that is given you. It's not very long. Take a picture of it, turn it in. It is due tomorrow. It's not very long, so therefore it's due pretty quick, okay? Glue this in on page 25, or you've written on page 25, and I will see you tomorrow.